Hello everybody. You guys are going to like this video. It's short, only 6 slides, and it's totally review. You guys knew this stuff forwards and backwards last fall in Algebra 2, so I'm sure you're going to have no problem with this. All right, here we go, moving forward. So, what are some of the vocabulary words that we talk about when we talk about a function that is linear? Well, one of the things we always talk about is the steepness of the slope of that linear equation when you put it on a graph. Graphically, we think of it as being the slope. Sometimes in a word problem, we think of it as the rate of change. There's a formula for the slope of a line. We also think of a linear equation being in slope-intercept form, y equals mx plus b. And we think about the different types of linear functions we might have. We might have two linear functions that are parallel to each other, or we might have linear functions that are perpendicular to each other. So let's talk about slope. Like I said, there's a formula for slope. The formula is to take 2 points, and it can be any 2 points on a line because the slope of a line is consistent, whether you're on the far left side of the line, the middle of the line, the right end of the line. The slope is always the same. So take any 2 points, x1, y1 for the first point, and x2, y2 for the second point, and then subtract the y coordinates and subtract the x coordinates. And it doesn't even matter what order you use the points in. It doesn't matter which point is point 1 and which point is point 2, as long as you do it in the same order on the top and the bottom. The common mistake when using this formula is to put the x's on top and the y's on the bottom because x comes first, right? But it's the opposite of that. It's the change in y, the difference between the y coordinates, over the change in x. Horizontal and vertical lines have a different slope situation. A horizontal line is flat and it has a slope of 0. I know you guys are thinking slope dude from last year. Sorry, that memory is burned into your minds. So yes, horizontal lines have no slope. This is no fun. Vertical lines are so steep that their slope is undefined, is what slope guy said, right? So horizontal lines, they're just y equals a number. Because y equals a number means that it has a slope of 0, 0 in front of the x. A vertical line is just x equals a number. It doesn't even have a y coordinate in it because the y coordinate can be anything. The x coordinate will always be whatever that number is. So for example, a horizontal line y equals 7 would be going right through the y-axis at 7. A vertical line x equals 7 would be straight up and down going through the x-axis at 7. So horizontal and vertical lines don't follow that pattern necessarily. Horizontal lines have a slope of 0 and vertical lines have an undefined slope. Parallel lines will have the same slope, or equal slopes you could say. Perpendicular lines will have slopes that are opposite reciprocals of each other. So for example, 7 and negative 1/7. Those would be two lines that have perpendicular slopes. Okay. A lot of times we're asked to find the equation of a line, whether it's in a word problem or in just a plain math problem. So there's a couple ways that might happen. If I give you the slope and one of the points on that line, any point on that line, you can use y equals mx plus b and plug in y, x, and m, the slope, and then solve for b. Or there's a formula, this is an example of finding it that way. There's also a formula called the point slope formula that you may have learned in an Algebra 1 class, but to me it's just another formula to memorize, so I just use y equals mx plus b, plug in x, y, and m, solve for b, and then give the equation in slope-intercept form, using the slope that was given to you and the y-intercept that you just solved for. Okay, what if they just give you 2 points? Then you have to find the slope first, using the slope formula. So you're going to use y2 minus y1 over x2 minus x1. The slope turns out to be negative 5 when you reduce that fraction. And then you're going to do the same thing that you just did in the previous example. You're going to take one of those 2 points that was given to you, along with the slope that you just calculated, and you're going to plug it in to y equals mx plus b until you find the y-intercept. This time the y-intercept turns out to be 11. And the slope of the line was negative 5 from our previous calculation. Plug it in. There you go. Now, if you know the equation of one line and you know a piece of information about another line, then you can find the new equation. So this one's pretty tricky because the line is given to us in standard form instead of slope-intercept form. So our first step is going to be to take what I've just circled in red there, the line that's in standard form, and rearrange it so that it's in slope-intercept form. So when you move the x term over to the right, divide by the -3, you end up with a slope of 2/3 for the original line. But we don't want a line that has that slope. We want a line that's perpendicular to that. So perpendicular to a line that has slope 2/3 would be a slope of -3/2. So -3/2 along with the new point that was given to us, plug it into y = mx plus b, solve for b, and there you go. There's your new line perpendicular to the original line. All right. If it was parallel, you would use the same 2/3 that was solved for when you rearranged the equation and put it into slope-intercept form. And you'd go through the same steps of using the 2/3 and the point that was given to you, solving for b, and then you would, sometimes you get a fraction, okay? It's okay to have a y-intercept that's a fraction. We're pretty used to seeing slopes as fractions, but not so used to seeing y-intercepts as fractions, but it happens a lot. So don't freak out if you get a fraction. All right, let's do a word problem. Gotta have a word problem, right? Because we love word problems. All right, in real life context, the slope is the rate of change. So a lot of times it'll be something that is a price per unit or miles per gallon, anything that is a rate, okay? So we have a lot of rates in our life. You may not realize it. There's the cost per month for your cell phone. There's the price per pound for grapes when you buy them in the store. There's lots of different things like that that are charged per something, or if it's not cost, maybe it's like inches per year that of rain that we get. So rates are slopes in real life problems. Now what's the y-intercept then in a real life linear problem? The y-intercept is oftentimes called the starting value or the initial value, or sometimes it's a one-time fee that you pay no matter what. So a fixed cost would be another way to say that. So here's an example. Danica is trying to encourage her classmates to donate books for the book drive at the local library. Danica will donate $35 plus 7 cents for each book donated by her classmates. Write an equation for D dollars that will be based on B books being donated. So they've given you the variables. Instead of X and Y, they've chosen D and B. And let's think about what's happening. She's going to pay $35 even if nobody else contributes. But if other people contribute, she's willing to pay 7 cents for each book. For each book sounds like multiplication to me. So 7 cents times 1 if 1 book is donated, 7 cents times 2 if 2 books are donated, and so forth. So that $35 is that initial value, call it B. 7 is a rate, it's per book. So we have the dollars that will be donated by Danica is 35 plus 7 cents times every book. Now they wrote it in y = mx plus b form because that's what we're used to seeing. Personally, I would like to see that D = 35 plus 0.07b, emphasizing that the 35 happens no matter what. It's a fixed cost, and then there's going to be 7 cents per book after that. Okay, now, what if you have more than one linear equation and you want to find out where they intersect each other or where they are equal to each other? Then you use a method called either the substitution method or the elimination method. First, you have to write 2 equations, though. So let's look at this two equations here. ABC Book Club charges $40 a month plus $2 per book read in that month. That's 40 plus 2b. Easy Book Club is $35 per month plus $3 per book read in that month. So maybe this is like a Kindle type thing. For each club, how many books must be read in 1 month for the total charges from each club to be equal? So if you make an equation for each club, like we talked about as I was reading through the problem, and then you set them equal to each other, you're basically doing a substitution method to find where they are the same. So how many months will the cost be exactly the same? So set the 2 equations equal to each other, basically D equaling D, and then do some slick algebra 1, move the like terms together onto the same side of the equation, and you get B = 5. So for 5 books, it doesn't matter which club you use. For one club, it's going to be cheaper in the beginning. For the second club, it's going to be cheaper later on down the road. So that's how you do a linear equation problem where you have 2 linear equations that you need to set equal to each other. So that's it for today. 10 minutes of teaching. You've got an assignment to do. I hope you remember all your linear equation solving skills, and don't be afraid of the word problems. All right, good luck. Bye.